Right, well this is take two, because the GoPro went all wrong and all the footage I've just shot is throwaway. So anyway, so a couple of weeks ago I was struggling with some pretty bad local QRM. It was like impossible to use the radio basically, at least with the M-Fed half wave. So I've had an antenna that a receive antenna that I've had for quite a while, and I've never used it, and it's one of these fairly cheap, I think it was about £30. It's an indoor loop antenna, and it's really meant for SDR receivers, and it's receive only. Well, apparently it'll take 250 milliwatts of transmit, so which is, it's no good plugged into a Yaesu 991A or something large, because they only go down to 5 watts, which would instantly let the smoke out. Anyway, so I plugged in this loop antenna into the Yaesu just to see, if I could receive anything, and I was kind of blown away by the results, to be honest. I mean, it was a quiet antenna, but the QRM had pretty much gone. So once I turned the preamp on the radio, signals started coming through. So I was very surprised. And then I got to thinking that it would be really nice if I could use that to receive and the N-Fed to transmit on. But that requires a radio that's got a receive, an RX port, antenna port, and you only really start getting them when you start getting into the high-end radios. You're talking £3,000 ish, to start getting that sort of functionality. I'm sure there probably are cheaper radios that have it, but certainly my 991A or the FTDX10 that doesn't have it. Doesn't have it. It's only it's a single antenna port. So I commented on this on the DX Commander Discord server, that it'd be really nice if I happened to have one of these radios, because I was getting quite good results out of this antenna. And in his typical fashion, my friend Mirko, 9A6KX in Croatia, appeared out of nowhere and posted a schematic that he'd quickly drawn up. This one, in fact. And it's plans for an antenna switch, a simple antenna switch. And so I got quite excited about that, and I thought, I'll give that a go. So I ordered a bunch of quality Schrack relays from made in Austria, and waited a couple of days, and they turned up. And I ordered 6 of them, because it's never a bad thing to have spares. But when they turned up, I realised, I'm pretty sure you can't see that, but they're 6-volt relays, and they're only single throw, whereas Mirko's schematic needed 12-volt relays and double throw. So I'd cocked up a bit there, and I mentioned it on the Discord, and Mirko said, "But don't worry about it, I'm busy at work at the moment, but when I get home this evening I'll send you over a new schematic," which he did. So this is the Nathan bought the wrong parts revision. So I think before I get into the functionality of it and things like that, I'll just do a quick couple of comments on putting projects into a proper box like this, because it makes all the difference. If it's just bodged together in a cheap plastic box, the RF's not going to be as good, and it's just going to be flimsy. And if you're going to use it, if you're building something that you're going to make good use of, then it's worth taking the time to put it in a decent enclosure. And it's like a guitar effects pedal box, so it's meant for guitarists to stomp on with their foot, so they're pretty substantial. And so just a quick word about tools. So what you'll need is at least these 2 things. So this is a punch, and this is a tapered hole drill thing. I don't know the proper name for them. So what I did was, using a Sharpie and a ruler, I'd draw a line so everything's sort of in line, and then I'll show you on this scrap piece of copper. So you've got a line across there, but done with a ruler, obviously, not just freehand. And then where you want your individual components, you just mark them out with a little cross over the line. And then carefully line up your punch, because it's easy to slip it around at this stage, but line it up and then press down and it'll spring, and it'll leave. I'm not going to do it because it will probably shatter this circuit board, but even in steel it'll leave a little dimple, an impression in the metal. Definitely does it on aluminium. And what that enables you to do is drill a pilot hole. So you don't start off with this because it's like 4mm at the end, and it's difficult. It's got nothing to grip on really. So I'd take something like a 2 or 3mm drill bit, and when you've got all your punch holes, just pilot hole it. What I actually did with this as well is using a set of calipers, which you don't have to have if you can find the datasheet specs for the diameters of these things, but it's much quicker if you've got calipers and you can just measure it. And then I jotted on over each hole how many millimeters the hole needed to be, so I didn't make any silly mistakes when I was doing the drilling. And then once you've got all your pilot holes in, you can go at it with one of these and get up to, I mean, this goes up to a 20mm hole. So I think the biggest on here is the SO239's at 16mm. So yeah, that's how you get a nice looking solid project box. So while I was waiting for some other parts to arrive, I was a bit stalled on the project, so I thought I'd put together the cables that are required. So this is a bit of a, it's not the best, is it? But it only needed one wire. So this plugs into the back of the accessory port on the Yaesu. Now the same plug will work on the 991 or the FTDX10. It will probably work with the 818. I think any Yaesu that's got the accessory port. And I pulled up the pin out for it, and identified which one was the TX ground pin. So it's basically when you key up on the radio, it pulls that to ground, and then I put an RCA on the end, so that goes into the PTT input as labelled there. For the power, which is probably a bit overkill, but you know, take pride in it, and these are good quality. It's a GX16 plug, which is used frequently in the aviation world because they screw on. So that is the power supply. So I'll give you a quick demo of its functionality. I'm not going to plug it into the radio because I'm missing some coax. I can't get it under the camera. But you'll get an idea of how it works if I can find a piece of wire. So how does what does it do? So we've got power into it now. Effectively, the radio is connected to obviously the radio port. You have your end-fed half wave or your DX command or whatever, your usual transmit receive antenna on the RX-TX port. And on the RX only, you have something like a loop on the ground or a indoor receive loop or something that you're experimenting with, but that will never see transmit power from the radio. So if I switch it on, well, in fact, first, even switched off, the signal path is to your transmit receive antenna, so your RX to your end fed half wave or something like that. So switched on, all it does is provide power to various bits of the circuit, which I'll show you in a while. So again, default signal path is to the RX-TX. If I switch it to the receive transmit mode, so it's not just using the transmit only antenna, then the signal path is no longer to the M-fed or whatever it is. Now you're on the receive only antenna, so while this is switched on, you're using the loop on the ground or, you know, whatever, your RX only. So then I'm going to simulate the radio calling PTT by pulling it to ground by using this piece of wire, and this case is grounded. Right, so that's in the TX, so we've got the end-fed half wave now, and the radio's going to transmit. So you can see the red LED comes on, it tells us it's in transmit mode. It'll help if I've got a proper connection between the sockets. So and so there, it's the automatic antenna switches between an RX, automatically switches between a receive only and a transmit or receive antenna. So it sort of brings functionality of a rather expensive radio to any radio effectively. It doesn't have to be Yaesu, it can be anything that's got PTT out. I think they all pull to ground, so it'll work with all of them. So let's have a look in the box. First off, capped on tape just in case, because this is effectively oriented that way in normal use, and everything's stuck to the case kind of upside down with double-sided foam tape. And I thought just if these relays come unstuck, and because of the nature of the connections between them, I think they'd all have to come undone at once, which is unlikely. But just in case they dropped against the grounded box, I don't want to damage the radio, so yeah, capped on tape all around. So it's pretty simple really. PTT, well, power in first, and then it goes through a 1 amp fuse. Always important to fuse everything, and that goes to your on-off switch, and then PTT in. But the radio can only handle 200 milliamps, which isn't enough to safely run these relays. So it goes into an optocoupler, there. So that gets switched on, which activates this BJT transistor, and that's taking the current to run all these relays. Hence the heatsink on it, which possibly might have been overkill, but you know, you don't want stuff getting too hot. And then you've got the antenna switch. So when it's active, it activates this relay. Now because it's a 6-volt relay, if you build this with 12 volt, you won't do this circuit, but because it's a 6-volt relay, there's a 2-watt 100 ohm resistor there, so this isn't getting over volted. And so this activates, basically that sends the signal path. When that's switched on, that sends the signal path to the receive only antenna, and then when PTT comes in, this gets switched. Well, in fact 3 relays get switched when PTT comes in, and that sends you off to the transmit antenna. Now this is effectively a dummy load. It's 4 200 ohm 1 watt carbon film resistors. And the only reason that's there is if your radio's transmitting, and for the split, you know, millisecond that relay takes to shift, you've got an infinite impedance on the well, basically you don't know where your RF's going. It's not going to be good for your radio. So just for like a millisecond or so, those resistors are going to be possibly just there for safety. They're going to be presenting the radio with a 50 ohm load until it switches to your antenna. But yeah, and again at the same time that this relay is activated by PTT, it switches on this little red relay, so red LED, so we know that it's transmitting. That's effectively it really. It's quite simple. This bit seems a little bit messy, but I don't know, just belt and braces. I didn't like the idea of solely having mechanical contacts to the ground, although they would have been perfectly fine, but I thought I'd just solder in some wire against all of these things. The LEDs are just a little spot of epoxy in there. I should have probably used hot glue, but I didn't have any to hand. So yeah, that's the that was a bit loud. That's the automatic antenna switch, and it's quite exciting that I've got the functionality of a very expensive radio on effectively any radio that's in my armoury. Well, my great thanks to Mirko for coming up with that schematic for me and helping me out, and you know, I encourage you to just, well, just tinker, go and have a play. If it's something that you think would be useful for you, it's not difficult to build. Take your time, it's fun. I found it a pleasure to just sit there and drill the box out. It was all very cathartic, so give it a go. 7.3.